Hey there, my name is Alejandro, and welcome back for day 21 of me doing the NeetCode 150 challenge. So today we're doing our very first intervals problem, and let's get straight into it. Okay, so sorry about that. I noticed that this problem is blocked by LeetCode Premium. I was gonna go and buy the LeetCode Premium subscription and so on. I was trying to research online, whether it's like okay to record problems of me doing like LeetCode Premium problems and so on. And so I was like looking if NeetCode, like he would record the premium problems and so on because I want to make sure that like I don't do anything illegal and so on. But then I noticed one thing quickly here, which is that if I don't click the external link and I click this link right here itself, NeetCode has actually added it's not on the LeetCode platform, but there is I suppose it's the same problem here on his website and so on. I don't know if he uses the same test cases. I hope that he does. Maybe I can try. So this returns like booleans, it seems like. So if I can run something like this. Okay. I guess it's like kind of simulates LeetCode. We can press submit to see like how many test cases there are total. So 23. Okay, so maybe he has like a subset of test cases and so on. But I guess for this, for now, this will do, right? So whenever there's a premium problem, we'll just do the NeetCode's website version of that problem instead, until either we reach a premium problem that's not on the NeetCode website, then I'll figure out something else to do and so on. But for now, otherwise, we'll just get straight into the problem. Whatever it is and so on. And so yeah, this is unfortunate. This is blocked by LeetCode Premium, but somehow NeetCode is able to post the question on here anyway. So like that definitely I could probably record. So we'll just get right on with it. So again, just for now and for the future reference, whenever there's a LeetCode Premium problem and NeetCode provides it here on this platform, I'll just solve that version instead. So without further ado, let's just get straight into it. So here we're doing meeting schedule, a LeetCode easy. All right, given an array of meeting times, of meeting time interval objects. Whoa, okay. Given an array of meeting time interval objects consisting of start and end times, start 1, end 1, okay, cool. Okay, so these are inclusive, I'm guessing. Start of I is less than end of I, okay. Determine if a person could add all meetings to their schedule without any conflicts. Okay. So you just gotta see if it overlaps anything, right? Okay, we've done a similar problem like this in one of the LeetCode dailies where it's like part of the problem we needed to check if it like overlaps. So right, we can essentially, how did we do this efficiently, right? We did like some leftmost binary search idea and so on. Oh, I have to remember this, right? This is also a LeetCode easy, so I just gotta check if there's any. Well, okay, I could also do like, kind of like an n squared algorithm. What is the constraints on this? If I move myself, okay, the constraints interval's length itself is up to 500, right? So it's like, okay, we can definitely do an n squared solution and that will work. I wonder if that is the optimal solution, right? So here we can just do something like, for I in range length of intervals. And then for any oh yeah, let me just remove my Discord otherwise really quickly. For I in range length of intervals, for any interval before that, right? So for j in range up to I but not inclusive, then we'll do, okay, this UI is not as fun. Okay, seems like I can't scroll up or down. Okay. For now, for premium problems, we'll just deal with this. For I in range length of intervals, for j in range I, we'll do S1 comma E1 is equal to intervals of I, S2 comma E2 is equal to intervals of J, right? And so how do we know? So one of the very first things that we could do is sort the intervals, right? So just do intervals dot sort for I in range length of intervals for J in range I. This is the smaller one, right? Small and end. A small, actually, key is equal to lambda interval. Interval of, we'll sort them by increasing finish times, right? Okay. And then we should also, so the very first thing we can do is like do the brute force solution, but then I think we can do something efficient with like leftmost binary search or something like that, right? So so for now, let's just do sort with keys equal to so they're sorted by increasing finish times, right? So here we'd have 10, 20, and then 30. So let's think about when an interval laps with each other, right? So it's like if we have S1 goes to E1 here, right? It overlaps if we have, you know, like S2 somewhere in here, and then this is like E2, right? Because again, like E1, so okay, these are by increasing finish times, right? So the J will have the smaller end time, right? So this will be small s, small end time. This will be big start time, big end time, right? So this will be small e, this will be big E, whatever it is, right? And it's like this is small s, or this is small s actually, this is big S. There we go, right? And it's like, okay, so this big E comes right after this small e, right? So they overlap if this big S is less than or equal to this one. Okay, first of all, how is an overlap considered, right? So it's like, is it the end are considered given array? Consists of start and end times. Are they inclusive, the start and end times? That's kind of ambiguous in this problem, right? Start of I is less than end of I. Determine if a person could add all meetings without any conflict. So it's like, is there a conflict at the same hour? Can I add a test case? Okay. Is there a conflict if I do 0 to 30 and then I do, you know, 30 to 60? Does this create a conflict? Here we'll just do return a false, right? Pass. My goodness me, what's going on? Why is it box/script.py? What? Okay, this website is a little bit buggy. Oh, does it not understand this? Does it not understand dot sort? So what if I comment intervals dot sort? Oh, I'm given a list of interval objects, so I don't even get them as tuples. What the heck? Wait, so here it tells me that I receive them as tuples, but that here I get them as objects. Okay, this is very bizarre. Okay, sure. First of all, we'll do intervals equals map lambda interval object into interval dot start and interval dot end, right? Intervals. And we're gonna do a sorted version of this guy with key is equal to lambda interval interval of 1, right? Because we're gonna say start comma end is equal to 0 comma 1, and here we'll do the end time, right? And there we go. So now we can just do print intervals. Okay. So now, yeah, I print them as like this, 0, 30, and 30, 60. Expected output is true. I can attend all my meetings without conflict. Okay. Right, so these 30s do not conflict with one another, essentially, right? So essentially I can consider them as like, this should not be brackets here. These should be open like parentheses, right? Again, it's just not very clear from the description of this question. Okay. No, 810, 810, 08, 810 is not considered a conflict at A. Okay, okay. So it can overlap exactly once. Okay, that's cool. I didn't read that little note here. Okay, let's keep solving this problem. Okay, so the very first thing is I convert intervals, right? I'm giving them as like these objects with like a self.start and a self.end here. I'm just gonna essentially map them into a sorted list of the intervals as start and end pairs, and then sort them by increasing finish time, right? Because that'll allow me to do something more efficient later on, because I remember of a LeetCode daily an idea. For now, let's just do things primitively. So right now we're just returning false. Okay, for I in range length of intervals, I plus 1 comma length of intervals, we'll just do anything remaining, right? So it's equal to I, and this is equal to J. Right? And so here there's the big and E, right? So if, so assert that small e is less than big E, right? Or less than or equal, we don't care. If big S is less than small e, return false. And here we do return true. Does something like this work? Okay, so that does work. So here we can press submit. Wrong answer. Oh, no, it's accepted. Okay, so we have an accepted solution. Yeah, so this solution that we just wrote is accepted. Okay. Okay. I love NeetCode, but I do like the LeetCode website a little more. So okay, no worries. Well, okay, so it seems like we got an accepted solution, so that's pretty cool. But okay, let's see if we can do this more efficiently, right? So here, this is like an n squared algorithm, right? We do O of n log n time to sort. Well, okay, O of n time to map all the intervals into like start and end pair, and then n log n time in order to sort those pairs by finish time, right? So O of n plus O of n log n is equal to O of n log n, right? So this takes O of n log n time. Okay, so now the idea is this. Okay, so if we consider, right, if we have them by increasing finish times, right, if we have them by increasing finish times, what was the idea that I essentially had last time, right? So essentially, it's like if by, oh yeah. So the other problem was essentially like, you know, figure out where you're going to add an interval if it doesn't conflict with anything, right? It was like, don't allow any double bookings, right? So anything that conflicts with an interval, otherwise add that as like, you know, a previous meeting. And then it's like, figure out if there's anything, right? So essentially here, actually this would be n log n, right? So if for every interval, I can see if it conflicts, actually, I would add it as exactly where it needs to be, right? Is there any follow-ups to this question? Tell me if I can do it in O of n time. No. Maybe this is the easy solution, right? I'm trying to think. Do I bother making this more efficient, right? Because I'm thinking there is probably a way to do so, right? If for every interval I figure out in log n time where it's supposed to be, right? The only problem is that maybe I have a set of scheduled intervals, right? And inside that set of scheduled intervals, scheduled is equal to this, right? And now for interval in intervals, S comma E is equal to interval. And now, okay, we're gonna leftmost binary search to figure out where it should be in scheduled, right? So essentially, okay, so how is this gonna work? Okay, so here we can do leftmost binary search, right? And here we're gonna have a definite with a self here, right? And we're gonna say self.scheduled is equal to an empty array. Here we'll do leftmost binary search self and interval. returns true if conflict, else false if no conflict. So I should actually rename this, right? Is there a conflict, right? But for now, let's just think about it this way, right? Want to find index I, if exists, such that interval of I self.intervals is equal to none, and self.intervals is equal to this, right? There we go. Dot intervals of I of 1, interval of 1, self.intervals of I plus 1 of 1. Right, so where it would fit in the food chain. Returns true if conflict, else false if no conflict. Okay, I'm just trying to make this. I'm making my life a little bit harder here, right? I just have to remember how I did it. Essentially, here we already have an accepted solution, so this is great. We're already able to solve the problem, and probably in the way that I expected. It's just here I'm trying to be fancy to see if there's a faster way that I can do things. Because this would make the overall running time complexity n log n instead of n squared, which would be very, very cool. And then we can check if NeetCode did an n squared or n log n algorithm. So here we're going to do leftmost binary search. Want to find index I if exists such that self.intervals of I1 is equal. Okay, so we're going to do a left comma right. Mid is equal to L plus R over 2. Actually, we might not need an L and an R, right? So essentially we do L comma R is equal to 0 comma length of self dot scheduled intervals minus 1, right? So we actually just need the interval is equal to interval. Well, L less than R, we'll do mid is equal to L plus R over 2, right? If start comma end s comma e is equal to self dot intervals at index mid. Or self dot scheduled at index mid, right? So scheduled are the intervals so far, right? That way we can just make this a little bit better. It's still going to be n log n, but it's technically just going to be a little bit better, right? So s comma e is equal to self dot scheduled mid. So here, yeah, I'm just trying to really think through this logic, right? I'm basically turning this into like an easy and turning it into a medium problem, right? But just to make this a little bit more efficient, going down from like n squared to n log n in case it is possible. Well, L is less than R. So the idea is essentially it's like I want to find log n time where I pretend I'm trying to like schedule these intervals, right? So it's like these intervals I want to schedule them, and I'm going to go one by one by scheduling them, right? And like I will have a kept track of like all the intervals that I've scheduled, and then for each next interval, right, it's like I want to go into my schedule and schedule it, right? And I will check in log n time. Okay, am I available to schedule it? If yes, then cool. Otherwise, it will return false, and I return false to the entire problem, right? And so it's just like instead of like having the full intervals array, and then for each of those, like okay, compare if there is a conflict and so on, right? Because then you can't like compare your own thing and so on. It makes things technically a little bit faster to only consider the ones that you've scheduled so far, right? So let's just do that. Mid is equal to L plus R over 2, S comma E is equal to self dot schedule of mid. If okay, so the very first thing that we should do, right, is case 1 belongs to start of interval. Case 2 belongs to end of interval. Okay, if start is greater than self.intervals or greater than or equal to self.scheduled, case 1, 2, 3, first scheduled first interval. If length of self.intervals is equal to 0, self.intervals dot append start comma end, and then return false. There was no conflict. No conflict. Can't schedule, right? Oh, but okay, we'll call that something else later. L comma R is equal to, yeah, so I just gotta be very careful about the logic here, right? So yeah, so this is technically constant time. So here I'm just worried about asymptotic complexity, right? We can't even see, like, you know, if we're better than like 60%, etc., blah, 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 blah. So for now, it's just like, let's try to come up with a solution that's technically overall n log n. And then once we do, call it a day, right? So case 2 belongs to start of intervals. So yeah, if, you know, end is less than or equal to the first interval's start. Right here, we'll say start comma end is equal to 0 comma 1 again. So first interval start. Then collections.deck of this stuff, because why not? That way we can add stuff to the beginning and end, right? Really, we should make it a linked list. Okay. Okay, it's just a lot of implementation details at this point, right? If start is less than or equal to, okay. If start is less than or equal to self.scheduled, of -1, yeah, so this should be scheduled as well. Of end. If the last scheduled intervals end is less than or equal to start, then here we're gonna do self.scheduled. Yeah, I just gotta make sure that I do scheduled. Dot append start comma end. Otherwise here self.scheduled dot append left start comma end. Right, there is no conflict. And in each of these cases I return false, no conflict. Here I'll return false, there was no conflict. Right? And then otherwise it's like, okay, let's figure out where I should be, right? So S comma E equals self.schedule of mid. If, so let's think about this, right? If E is less than or equal to end, right? Or if E is greater than end, really, okay, it's leftmost binary search. So I want to find the leftmost occurrence. Right, okay, so I'm just going to do that. Let's put that here. In other words, find leftmost occurrence index I such that end is less than or equal to self.intervals of I of end. Equals R. Leftmost index is equal to R. Well, I is less than R. Mid is equal to this. If E is less than or equal to if end, okay, if end is less than or equal to this E, right? is less than or equal to e, leftmost index equals min of leftmost index, comma mid. Right? Otherwise, it's like, okay, n is less than or equal to e. There might be more cases where n is less than or equal to e for even smaller e, right? So we should search in the right sub and the left sub half, right? So now r is equal to mid minus 1. Else, okay, just give me 1 second. Okay, sorry about that. That was just my roommate there. Let's just keep on going. So else, you know, if n is greater than e, so n is greater than this guy, so it's too big. So we want to keep searching in the left sub half. Wait, okay, let me think about this. We want our end interval. Okay, we want to find the leftmost occurrence such that this is still true, right? So if this is true, we might not have found the leftmost occurrence. Okay, so now why do we want to search the rightmost occurrence here then, right? If n is if n is greater than, right, we're going to keep going rightwards where the interval's ends are even greater because everything is sorted by increasing finish time, right? So L is equal to mid plus 1. So now we have our leftmost index, right? Small e, comma big E, small e equals self.intervals at leftmost index minus 1. Big E equals self.intervals at leftmost index. Right? Assert a small e less than or equal to and less than or equal to big E, right? We probably only have to check if it conflicts with one of these intervals, and I just have to think about the which one which. Otherwise, we know we can lazily just check if it conflicts with both, right? I gotta think here. There's just the yeah. There's a lot of logistics. Okay, I kind of wish this was only code. I'm not gonna lie. Small e self.intervals leftmost index minus 1. Big E self.intervals leftmost index. Small e and less than or equal to big E. Right, so essentially I will have small e, small s points to small e, and somewhere in here, you know, I'll have, you know, big S points to big E, and then it's like my end is in between these two guys. So this is where my end is, right? So first of all, we know that these guys do not conflict with one another, right? So this must be at least, you know, where these guys are together. So these at least do not conflict, right? Which means that this is even further apart, right? My end might even be here. So it depends on where my start is, right? Maybe I do check if it interferes with either interval, right? So I check if my end interferes with this interval, and I check if my start interferes with this interval. Small s comma small e, big S, big E. Def intervals conflict. Self interval 1, interval 2. Small, comma s, comma small, comma e equals I1. Big S, comma big E is equal to I2. The big E is smaller than small e, then small s, comma small e actually need to be I2, and then big S, comma big E actually need to be I1. And here's the conflict logic, right? Return true. Intervals conflict, right? So here let's test if things work, right? So let's just run this. Oh gosh, where do I have the for loop error? It doesn't give me the red squiggly like on LeetCode. Oh yeah, here. If self.intervals conflict, intervals of I, intervals of j, return false. Jeez. Oh, I need to do import collections? Oh gosh. So maybe I just can't do collections.deck on the NeetCode website? What's going on? We'll do self.intervals, self.intervals. Bro. Okay, we'll put these guys back. Ah, come on. Oh yeah, we'll do self.intervals, self.intervals. Okay. Oh. Return false, but here's like return true that they conflict, right? Otherwise return false. Yeah, okay. If I submit this, then it's like, okay, I have an accepted solution. Okay, so I have an intervals conflict method that works, right? And here instead of this, I can just do essentially just return big S is less than small e. True if conflict. Okay. Now, there we go. If self dot intervals conflict with small s, small e, and my current start comma end, turn true, conflict. Same thing, big S, big E, and true conflict, return false. So here we'll, so here we'll do def is conflict, self comma interval. And this modifies our self.schedule, right? no conflict, add into scheduled. So here we'll do, so this is the leftmost index, right? So it should be added at that index right before the biggest one. Okay, so self.scheduled.insert, how does insert work in Python? Python 3, how does it go to the 1, 2, 3? So r.insert insert at index 0 and number 5. Alright, so like wherever that index, yeah, okay. Insert at index, whatever is the index, right? Leftmost index. Comma start, comma end. So here, intervals conflict, right? So here we can do for interval in self.intervals. So this left is conflict, returns true if conflict. If self dot is conflict interval, and return false. Return true. Something like this work. Oh gosh. Start. Start comma end is equal to interval. And where's the other start comma end definition? There we go. Okay. So I have the assertion error. Here, this is interesting, right? So print self.scheduled and leftmost index. And the interval. So 0, 30, 0, 1. We'll do r plus 1 for now. Okay, that's it, just like add at the end. Okay, if I submit something like this, does it work? Oh, it does work. Okay, we actually got it. That's actually amazing. Okay, that's actually incredible. Length of self.scheduled. Oh my goodness, that's actually incredible. I thought I was gonna get like kind of like lost in the details. Oh my goodness, that's actually incredible. That means that we actually figured out how to write this in n log n over all time. This is actually amazing. Okay, it's gonna be a lot of code, and it's on this UI that I'm not familiar with. Honestly, okay, I know I was like kind of like talking smack about this UI and so on. Like, LeetCode probably has a team of developers. NeetCode is all alone and so on. Like, shout out to NeetCode, right? Probably I don't know how NeetCode is, but if he's in his 20s and so on, he's just a normal developer. Like he coded this entire website on, cloned it and so on, added test cases, makes the code run. So probably uses some external library and so on. Like, like shout out to that boy. Like that's actually like kind of an impressive feat. So honestly, like for what he was able to build alone, this is pretty impressive. So shout out to NeetCode. But yeah, it's just like if I got used to this UI, like it would probably be okay. It's just again, I'm very, very used to that LeetCode UI. Okay, so here we can get rid of this stuff, right? So here we'll return true. Okay, so I've made things kind of modifies self.scheduled for currently scheduled meetings without conflict, right? I wish it would tell you, like, yeah, like if I saw this on LeetCode, it would be nice. Maybe I should buy premium just for that, but like, it would tell you like how much faster you are than other people. Because in this case, I would really be curious to see, right? So case 2, we actually can probably get rid of this one, right? Yeah. And if I submit this, yeah. So we actually can get rid of case 2. So I'll just put not needed. because yeah, again, it's just I'm getting like, you know, leftmost of the right, so it's like rightmost of the left. So yeah, I just don't like, I know that might not make sense. This technically is like some schedule.append self.intervals of 0 in range 1 all the way up to the length of self.intervals dot intervals at index I. First interval cannot conflict, so add directly. And what is the length of intervals? There's a constraint. Okay, so we mark it of length 0, right? So delta intervals here. So if length of intervals is less than or equal to 0, i.e. it's equal to 0, then return true. All right, that we can, right? Yeah. So preemptively return true, otherwise we have at least one element, and that way it's like I don't have to call this case here and so on every single time, right? So something like this should still work. Okay, very cool. And again, if I submit it, this should still work. Okay, very nice. Okay, so again, it's just like on LeetCode, like, you know, these are little optimizations that would make things faster and faster and faster and faster. Okay, let's just clean up otherwise some of the stuff. I'll leave these as commented out cases because of, they used to exist before. Okay, definitely. I can get rid of that print statement. I can get rid of this assert. Oh, actually, okay. Insert will technically be of n time. So final solution is now of n squared log n instead of n log n. We could make final solution okay. Technically this is n squared log n. That's very, you know, and I was like saying like, okay, if we use a linked list, we can add things like, you know, very efficiently. Okay. Final, so oh yeah, O of n log n by leveraging an AVL tree for this instead of using leftmost binary search allows us to do of log n lookup times, but of n insertion times linked list as of 1 insertion, but of n lookup. Therefore, with AVL tree, we could apply similar idea to achieve of log n lookup and insertion, conflict lookup and insertion times. But I will not do it right now. I'm lazy. Okay. I mean, I just like, I don't want to like remember how to do rotations and all that stuff and so on like right now. But, like, this would be a good opportunity to implement like an AVL tree and so on, but I figured this video is already getting kind of long and the conceptual idea behind it is kind of what matters, right? So okay, as always, I'll do a quick recap of how I was able to solve this problem. So I'll just come up and show my very first accepted solution here, right? Because that's probably the best one. Or maybe here very first accept. Okay, no. So this is with leftmost binary search. So let me put that away. So okay, so here at the very beginning, this was essentially my very first submission. So here is just like, okay, with these intervals, we would just want to return true if you're able to schedule them all, i.e. if non-conflict with one another. And note that something like 0, 8, 8, 10 is not considered a conflict because it's like, okay, it's like, think of the start time as inclusive, but the end time is not inclusive, right? So this is up to 8, not including 8, and this is starting from 8, including 8, but not up to exactly 10, so on. So think of it that way. That way, that's why these do not conflict, right? And so the trivial solution that I came up with at the very beginning is essentially like for every, we're just gonna do an n squared loop for every like single pair of intervals, right? And then for each of those two intervals, so we're gonna consider every single pair of intervals, and for each of those pairs, we're gonna check if the intervals conflict, right? And so the way we can check if the intervals conflict is we take whichever one has the bigger end time, right? So like for example here, like big end time comes after this small end time here. Maybe if I do this, this makes more sense, right? So this one big comes after this small. Even if they're equal, that's not what matters. So the only way these don't conflict is if this big S here is like exactly equal to or larger than small e, right? Otherwise, if it's before small e, even if it's before or after small s, here there's clearly a conflict, right? So that's why I say like, okay, if this big S, which is this big S over here, right? Big in the sense that it belongs to the interval with the bigger end time, right? So it's like the one with the bigger end time, even if they're equal, the big S is essentially that big intervals starting time, and small s is essentially the small intervals starting time, with big and small again referring to the end time. And so it's like if that the big interval starting time is strictly less than the small intervals ending time, then that means it's like a situation like this where there is a conflict, so we directly return false. Otherwise, if we've exhausted every single pair in between of intervals, and for every single pair of intervals there was not a conflict, then we return true, right? Now here I was trying to be a little tricky, and I was like, okay, what if we simulate this idea like for real, right? Where it's like at the very beginning we have 0 scheduled intervals, and then we're just gonna keep trying to schedule an interval and see if it conflicts. If it conflicts, we'll just return false for the whole problem. Otherwise, cool, we'll add that to our scheduled array, and there we go, bada bing, bada boom. And so the way that I did things is like essentially for every single, oh, so yeah, I'll just look at my last solution here, right? Because that's when I'll have the less stuff. Essentially here, I do the same things, right? Here's just a base case, right? If there's 0 intervals, there's no conflicts. Here, otherwise, I sort all the intervals. First, this map, all this does is I convert them from these interval objects to like tuples of start and end times, and then I essentially sort them by increasing or non-decreasing finish times, right? So the end times is what I sort these guys by in increasing order, or should say non-decreasing in case there's ties, right? So let me drink some water. Essentially here, I say like, okay, we're going to add the very first interval, right? Because a scheduled is essentially going to be our schedule intervals, right? And we're just going to keep scheduling an interval for every interval in intervals, essentially in this sorted list of intervals, right? Now sorted by increasing end times. Essentially, we're going to add the very first interval, right? Because that cannot have any conflicts. We have not scheduled anything, so it doesn't matter where the first interval is. There cannot be any conflict, so let's just add it, right? And then for all the remaining intervals, we're going to check if there is a conflict, right? And schedule it if so. And if there is a conflict, right, then we're going to return false, right? At least one of the intervals had a conflict, just return false, and it's not possible to schedule this. Otherwise, if we've gone through every single interval, quote unquote, scheduled it, and we have never had a conflict, then we return true. So now let's just look at how we did this as conflict function. So here, by the way, I just have a helper that just is the same thing, right? If like big S is less than small e, so I just have a helper method that helps me check if two intervals conflict. So that's just a helpful little helper. But otherwise here I have this is conflict method. And essentially all this does is I use leftmost binary search, the idea of leftmost binary search, to find the leftmost index in log n time such that, like let's say an index I, the leftmost index I, such that the end time at that index I is greater than or equal to my current interval's end time, right? So here in is conflict, I'm trying to schedule a current interval, right? If it's schedulable, I will add it to scheduled here, right? And I will return false because there was no conflict, right? I really should call this like, you know, like can schedule, and like and if you can schedule, actually schedule it, right? So on. So sorry, I'm losing my train of thought, right? But the point is like, okay, return false if there is no conflict, and if there is no conflict, I will also add it into my schedule array, right? But the point is I use leftmost binary search to find the leftmost index such that at that index, the end time is greater than or equal to the current interval that I'm trying to n time, right? And so if you've never seen this before, again, here I'm being a little lazy. Here is just like the L point or whatever it is will be like the leftmost and blah, blah, blah. But here I'm just like, okay, every time I see that this condition is met, right, n is less than or equal to e, I will make my leftmost index to be the smaller between the current leftmost index and the current mid element that actually satisfied this condition, right? And at the very beginning here, I say my leftmost index is equal to the end of the array, just so that way, how do you say it? Just an impossible index at the very beginning from the very end, and it's like that way it's like, okay, whenever I find a valid index, then I do the min and so on. And the reason I'm not worried about this being an invalid index where I'm trying to index here is because I consider the case where it goes to the very, very last interval, right? So it's like if the interval we're trying to add belongs to the end, then that means like, okay, let's just add it to the end there, right? And otherwise, bada bing, bada boom. So, and the way that I check that, right, is if since scheduled is also sorted by increasing finish times, right? If the last interval's finish time is less than or equal to my current interval start time, right? Then the intervals do not conflict, and I can add that to the very end, right? Because start is definitely guaranteed to be less than end, so that I'll still have the sorted property. That's where the interval belongs. So again, it's just like if it belongs to the very, very end of the schedule, then I'll just add it to the end of schedule, right? And that's why I know my leftmost index will actually be a valid index at some point, right? And here, this is just typical binary search. Typical binary search is, again, I update leftmost index to be the minimum of the current leftmost index and mid whenever I find a valid mid index that satisfies this condition, right? That way I get the leftmost actual valid index. And so here, let's just keep on going. So here I have the leftmost index such that it is less than or equal to greater than or equal to n, which means that the index before that must actually be less than n, right? And so that way it's like, okay, if I were to add it into scheduled, I would essentially add it before this element, but after the element that comes previous to this, right? Because the previous element to this, again, here the previous element is at leftmost index -1, and the current element is at leftmost index, right? So it's like there's going to be this big S and this big E. We know that since they're both in schedule, they do not overlap. So that's why I'm putting like this small e and this big S are like far apart from each other. They can also be overlapping with each other directly, right? And all I know is that this n value is between this small e and this big E, right? Because I know it's big E is greater or equal to n, right? But it's also the leftmost index where this actually holds, right? So it must be that this end is actually strictly greater than the previous element's ending time, right? So that's why it's like all I know is between this small e and this big E lies this end, which end might actually be equal to big E as well, and so on, right? And so the point is that like, okay, if there is a conflict, it is either going to be with this interval or it's going to be with this interval, right? I might get away with just checking for one of the two, but worst case is like we know like, okay, if there's a conflict, that it's going to be with one of these two intervals, right? If not more. And so it's like, okay, if there is so we check if there's a conflict with this guy and this guy, right? So we use our intervals conflict method that just applies the same logic as before. And if there is a conflict, then it's like, okay, return true because there was a conflict, right? This method returns true if there's a conflict. And remember, like, if we check that if at any point we return true, we'll return false for the actual function. It is not possible to meet, right? It may be a bit confusing with the booleans. I could have done things a little bit better, but that's essentially how I was implementing it. So if there's a conflict, return true to indicate a conflict. And then we do this with both intervals, right? Start and end is the interval that we want to add. We set start, comma, end is equal to the interval. And then it's like, okay, if this interval conflicts with either big S and big E or small s and small e, which again, big S and big E is equal to the leftmost occurrence of like where this condition holds, and this is the one that's right before it, right? So it's like it'll be like n is actually greater than delta intervals -1 colon n time. And so it's like, okay, we just have to check if it conflicts with either of these two intervals, right? And if it doesn't conflict with one of these two intervals, then we add that into our scheduled array because we can actually schedule it and return false to indicate no conflict, right? So this is all nice and handy, which is like this part is actually log n time. So the total running time complexity will be with this self that is conflict. So essentially we go through a for loop for every single interval, of which there are n intervals, and if this takes log n time, then beautiful, it's just n times log n, right? And this part is also n log n. So n log n plus n log n would give us a solution that it's total time n log n, which is better than the n squared solution, right? But not so fast, because now when I want to insert this new interval inside my scheduled array at that leftmost index, this is going to actually take O of n time. So this whole function is now O of n time instead of log n time, right? And so it's like if this is O of n time and this is O of n time, then the entire algorithm is n squared. It's actually not n squared log n, so it is actually n squared. So it is just as good as the previous algorithm. And now you might think like, okay, what if we use something like a linked list? That way we could insert things in O of 1 time and not deal with this O of n insertion time, right? The problem with the linked list is I can't do leftmost binary search in O of log n time, right? Because I need to go through the whole linked list. So linked list, while it might have a very fast insertion time, it has a very slow lookup time. So the way that you would actually solve this problem, which I'm too lazy to implement here because again, like I don't want this video to be like extremely too long, especially for an easy problem, is essentially you would use an AVL tree. An AVL tree, if you don't know, is essentially a binary search tree with the property that it will always be height balanced, right? So it's like if for any node, the height of the left and right subtrees will differ by at most 1, right? So it's like it will be a balanced binary tree, which means that insertion times will always be log n time in terms of asymptotic complexity, as well as lookup times will be log n times. Everything will essentially be log n times. So essentially it would allow us to do this problem with like inserting into a scheduled array. In this case, it would be an AVL tree. We would be able to insert in log n time, and we would also be able to search for a conflict in log n time, right? So that's why using an AVL tree here would be very nice, but there's a lot of details and so on. I don't want to do it with a BST because with a BST, technically you can get unlucky and like, you know, the whole binary search tree ends up being a linked list. So the asymptotic complexity is still n squared. With an AVL tree, since it self-fixes itself to be height balanced, everything will actually be asymptotically of log n. It's just that, again, it would take me forever to implement an AVL tree right now and so on, like at least another hour. And also, I'm not able to see like, you know, how fast I'm doing in comparison to others in this question and so on. So at least like, hopefully you would understand the idea of how I'm able to do this. So it's like, if you're able to understand this leftmost binary search idea and so on, then you should probably understand why it would work with a self-balancing tree, right? It's just that here, the bottleneck is the fact that inserting into my scheduled array at this index actually takes O of n time, right? Because what Python will do is we'll essentially extend the array by 1 element each time. And so add something in there, like create a new array of size n plus 1, and then just add the elements there and copy everything into it, right? So it's O of n time. It's very, very, very inefficient, right? But again, if I use something like an AVL tree, this would be log n time. I can essentially do the same ideas here with the AVL tree to make things in log n time. And that way it's like I could essentially check if things are a conflict in log n time. So I could, with an AVL tree, I could build this function again to run in log n time, which would make this whole portion now n iterations of this log n time iterating algorithm. So that would make this part n log n as well as this part n log n. So I would have an overall n log n solution, right? So what this proves is that this problem can be solved in O of n log n time. I don't know about O of n, but this is essentially how I would do it to make it O of n log n time. But again, I will not implement the AVL tree and so on. That's just like, you know, as they say in university, left is an exercise for the reader, right? Because it's just getting into the weeds and so on. The overall idea is there, like I understand what I need to do if I want to make it n log n. So that's really what I care about. We already have an accepted solution. So that's essentially what matters here. But in case you were curious about how to make this n log n, this is how. Okay, one thing that I'm curious though is like, let's see what NeetCode solution is. So what does it do? Oh, is there an O of n solution? Okay, no. So this is n log n, intervals.sort. Okay, for I in range 1 intervals. There's no way. Bruh. That's, oh my goodness, I'm so silly. Right, I was so thinking in terms of the other problem, where the problem is that, oh my goodness. You cannot be for real right now. Okay, at least I knew that it was possible to do this problem in n log n time, and I figured out a way that I could do it. So asymptotically, I knew how to do it in n log n time, but obviously, like the overhead of that is going to be way slower and way more complicated than this little solution here. So okay, the reason I went on a tangent, that's kind of embarrassing, is because I solved a problem in the past that essentially is kind of the same problems. You want to see if like there are any conflicts, but you don't know the intervals ahead of time, right? So the point is that like every single time you're going to be asked via like an API call, it's like a design question, right? Where it's like, okay, can I schedule this interval, right? And then it's like, okay, you got to look through all the intervals you've already scheduled and see if there's a conflict, otherwise add it in there and so on. Here, there's no adding and so on. You already have the full list of intervals. So of course you can just sort the intervals by what? Did he sort it by increasing finish time? Oh, he increased it by increasing start time, right? But okay, so probably the same idea and so on. That's just such a big shame. But yeah, so in that problem, essentially you had you didn't have access to all the intervals. You'd be adding them one by one. So each time you had to check, and you had to do that as efficiently as you could, right? So that's why there was that whole like leftmost binary search, blah 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 ideas and so on. So I just really overcomplicated this in my head. Like here, the thing to realize is like you have all the intervals ahead of time already. You just want to check if there is a conflict, right? So we might as well try to implement it this way. So you know what? Let's just restart this problem. I will just keep one thing here, which is this. Okay, let's reset this code. Okay. So here we'll do intervals dot sort based on lambda interval dot end, right? So instead of converting them into pairs of left and right, we'll just keep it as the nodes like NeetCode did, and you know what, let's just keep it like this, right? Or actually, you know what, intervals, sorted intervals is equal to, okay, it's just, yeah, let's just not make our life complicated, right? So here we have intervals dot sort, lambda interval, yeah, we sort them by increasing finish times. He did by increasing start times, but I like sorting by increasing finish times. And that way it's like, okay, I already have them by increasing finish time, so we might as well just like, okay, for I in range 1 all the way to length of intervals, right? We'll do small. I'm actually such a silly goof. That's okay. But that's what I mean. Like, you know, like this channel is like, the point is that like I will just be recording myself, like how my thought process as I go through these problems and so on. They're not necessarily like solution videos, but yeah. So it just that makes me feel a little silly. I'm not even gonna lie. Okay, so intervals at index I. Dot start and intervals at index I dot end, right? That's the only reason why I don't like it that way, but we can just do things this way, right? So big S big E is equal to intervals I, oh, there should be -1, right? And there should be -1. Intervals I dot start and intervals I dot end, right? And it's just like, okay, this is like the same thing where it's like we have small s, it has a bunch of stuff here, and this is small e, and then here it's like we have some stuff, we know our big E comes afterwards, but the question really is just where does the small s lie, right? So it's like, is our small s, so our small s, if it is strictly less than small e, right? Here big S, big S, big S. Right. So this has a conflict, right? Because big S is strictly smaller than small e. Here there is no conflict because big S and small e are the same. Big S, i.e. big S less than small e, i.e. big S equals small e, i.e. big S greater than small e, right? So only this one is considered a conflict, right? If they're the same and so on, there is no conflict. Again, it's like the same thing as this note, but otherwise if it's smaller, then there is a conflict, right? So from this point on, let's just move this a little bit over here so that this is a bit more readable. right? Again, like this one that's strictly, it needs to be strictly less than this small e, right? And again, a small and big e, right? Just this represents the big interval because it's one with the bigger increasing finish time, right? Because I sorted them by non-decreasing or increasing n times, non-decreasing n time or increasing n times, right? This is the more formal term and so on, but this is just like, you know, more human readable. Okay. So here's the only time there's a conflict. So if big S is less than small e, then return false. Otherwise, here we return true. Yeah, so this is key equals. Yep. Yeah, so this passes. And yeah, it's just, I feel so dumb. Okay. But yeah, now this makes sense, right? The whole point is that, like, okay, for each intervals, we're just going to go pair by pair. We have them sorted and so on. So it's like, you know, like, if there is no conflict between these two, then there is no conflict for these two with like any of the other ones, right? Because it's like, if there was a conflict to start, like if there was any other conflict, like these two would conflict. Like, again, it's just like, you're just gonna go through every pair of intervals in sorted order and just make sure that there are no conflicts, right? It's the same idea with like the schedule with the leftmost binary search, where it's like, you know, again, it's like I find out, like, you know, the leftmost index where it's like less than or equal and so on, then I like put it in there if it's schedulable, and I check if there's a conflict with the other one and so on. Here we just do things directly side by side, because again, we already have all the intervals, we already have them in sorted orders, so we can just do a linear scan and check if there are any conflicts between the direct pairs, because those are the only ones that are relevant for, like, again, like the same reasons as discussed before and so on. So okay, that's just a silly goof on my part. So yeah, there is definitely a way to do this in n log n. That is something that I realized. I didn't realize how trivial it would legitimately be. It's just that I was so focused in terms of that LeetCode daily problem. I think it was like at the end of September, we were doing like design problems. And one of the design problems was like very similar in terms of this, where it's like you don't have the intervals ahead of time, you need to like schedule them, and so you needed to get fancy with stuff like leftmost binary search, or like really the optimal solution would be to use like an AVL tree, right? And so to get that n log n performance overall, kind of like in here, it's just that like here the problem is technically an easy and not a medium, because again, you have all the intervals ahead of time, so you can just get away with a little trick like this and be able to do this. But otherwise, with that explanation and this one and so on, I hope that the whole problem makes sense and so on, right? That this should also be able to be understood as well. He does it by increasing start times, but the logic is very similar. It's just, to me, whenever I deal with interval problems, I like sorting by increasing finish times. It just makes things a little bit easier for me to think about. And yeah, that is pretty much all. So I hope that explanation was useful. In that case, I will go back to the NeetCode 150 if I figure out how. Yeah, so we'll come back here. And oh, okay, it already checks the box that I already did it, because it recognizes that I was able to solve it. Does this show my solution here? No, just his own solution. And this is with the start times, right? Oh, it's just a different from what he has in there. But yeah, he does it by I and index 0 because it's start times and so on. So yeah. Okay, makes sense. But okay, so it already has the box check that I did it because of the fact that like it was on his website and not the LeetCode website. And so yeah, so otherwise, that's pretty much it for this video. I hope that you found it useful or enjoyable in any way, shape, or form. I know it's a little bit of a long one, but at least there was some good learning outcomes in this problem and so on. So sometimes, like, I have to realize that this is a LeetCode easy, right? There's no way you're gonna do like leftmost binary search and so on, implement an AVL tree and all that fun business and jazz and so on. I thought that the reason this was a LeetCode easy was because of the n-squared solution, and that n-squared solution is acceptable. I didn't realize how trivial the n log n solution would be. And again, it's just because I got stuck with that LeetCode daily in mind and so on, where it was essentially this problem, but a little bit harder, because you don't get all the intervals all in advance, you add them one by one, so you need to still allow for that efficiently. But otherwise, again, that's pretty much it for this video. I hope that you found it useful and enjoyable, and if you did, I would highly appreciate if you left a like or a comment. But otherwise, I will catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.